Hello everyone and welcome to PadhaiX. In this video, we'll solve NCERT Class 11 Physics question 3.8 from the chapter Motion in a Plane. So let's first read the question carefully. Question number 3.8. A particle starts from the origin at t equal to 0 second with a velocity of 10 j meter per second and moves in the xy plane with a constant acceleration of 8I plus 2j meter per second squared. A. At what time is the x coordinate of the particle 16 meters? What is the y-coordinate of the particle at that time? B. What is the speed of the particle at that instant? Now that we've understood the question, let's solve it step by step.
Before jumping into the solution, let's first visualize the given situation. We have an xy coordinate system and a particle located at the origin. At t equal to 0 second, the particle has an initial velocity of 10 meter per second in the positive y direction. At the same time, a constant acceleration of 8I plus 2j meter per second squared acts on the particle. Now let's resolve this acceleration into its components. Along the x-axis, the acceleration is 8 meter per second squared. Along the y-axis, the acceleration is 2 meter per second squared. So if we observe the motion separately, along the x-axis, the particle moves with a constant acceleration of 8 meter per second squared, while along the y-axis, it moves with a constant acceleration of 2 meter per second squared. And when these two motions combine, the particle moves in the xy plane with an acceleration of 8I plus 2j meter per second squared. Now let's come back to the question. In part A, we need to find the time taken by the particle to reach 16 meters along the x-axis. To make the solution easier, let's first study the motion only along the x-axis. At t, 0 second, the particle is at the origin. Its initial velocity along the x-axis is 0. Notice that the particle initially has velocity only along the y-axis. Along the x-axis, the only quantity causing motion is the constant acceleration of 8 meter per second squared. This acceleration gradually increases the particle's velocity and moves it along the positive x direction. Now suppose after t seconds, the particle has traveled 16 meters along the x-axis. Our goal is to find this value of t. Before starting the calculation, let's recall the three equations of motion. Among these equations, we already know the distance covered, the initial velocity, and the acceleration. Therefore, the third equation of motion is the most suitable. Now let's calculate. Along the x-axis, Sx equal ux t plus half x t squared. Substituting the given values, 16 equals 0 plus half x 8x t squared. So, 16 equal 4t squared. Therefore, t squared equal 4, which gives t equal 2 seconds. Hence, the particle takes 2 seconds to travel 16 meters along the x-axis. Now we also have to find the y-coordinate of the particle at this same instant. That is, at t equal 2 seconds. So let's study the motion along the y-axis. Initially, the particle has an upward velocity of 10 meter per second and an acceleration of 2 meter per second squared. Again, we'll use the third equation of motion. Substituting the values, psi equal 10x2 plus half x2 squared. On solving, we get psi equal 24 meters. This means, after 2 seconds, the particle has traveled 24 meters along the y-axis. Therefore, the coordinates of the particle at t equal 2 seconds are 16, 24. Now let's solve part B. We have to find the speed of the particle at t equal 2 seconds. Since we know the initial velocity, the acceleration, and the time, we'll use the first equation of motion. We'll first calculate the velocity components along the x-axis and y-axis separately, and then combine them to obtain the resultant speed. First, along the x-axis, Vx equal ux plus xt. Substituting the values, Vx equals 0 plus 8x2, 116 meter per second. Similarly, along the y-axis, y equal 10 plus 2x2. So y equal 14 meter per second. Now we have both velocity components. Therefore, the speed of the particle is under root of Vx squared plus vi squared. Substituting the values, speed equal under root of 16 squared plus 14 squared. This becomes under root of 256 plus 196, which is under root of 452, or approximately 21.26 meter per second. Hence, the speed of the particle after 2 seconds is 21.26 meter per second. And with this, we have successfully solved NCERT Class 11 Physics, question 3.18. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to PadhaiX for more NCERT physics solutions. Thank you for watching, and I'll see you in the next video, where we'll solve question 3.19.